everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire, and today we've got Laith, who has just completed the course ROS2 TF course, and he'll be giving us a presentation on that. So without further ado, I'll now hand over the platform to him so he can begin his presentation. And as usual, we begin by seeing him doing the demonstration on the real robot first. Okay, so let me hand over to him now. Okay, whenever you're ready, Laith.
So now I'm ready.
Go ahead and start your presentation. Yep.
Okay. So for the starting now, because inaccurate results by the base of the robots, I'll depend on the map framework because it gives us more accurate on localization of the robot. So for that, I launched the map on RVIZ firstly. No, it should be. As we can see now on the RVIZ, the map is opened. The second thing that I'll do is that I'll drive the robot to a point that I can use it to localize the location of the robot. So for that, I'll use the T-Lobe twist keyboard node to control the robot. Now I'm controlling the robot. I'll take it to point. So I'll choose it on the map, like to estimate the localization of the place of the robot. So now I'll use to do pose estimate. Give it time. So now the robot is launched on the map. Now I'll run my first node, which execute the first task. In this task, we'll detect the features, the corners, and the obstacles on the environment. Firstly, I'll source my workspace, so I'll open it. I'll run my node. Feature detection. So now my node is working. Inside my node, it's a server, a service. This service, by incoming request, it will detect either corners or obstacles. So for sending the request, also I'll source my workspace in this terminal here. Now I'll start by detecting the corners. I'll start in corners. I'll control my robot and drive it to the nearest corner.
Okay.
Give it time. Now I send the request. I'll put the name of the service, which is feature. Detection, and the interface, the message interface, which is the, and now I send the first request. The feature, it's corner. And the feature ID is 1.
Okay.
it detected the first corner, so I'll move to the next corner.
Okay.
Give him a little bit time to correct the LiDAR reading.
Mm-hmm.
And then send same request, but now it's the feature ID number 2.
Okay.
And detect it. So I'll move to the third one. Give him a little bit time to correct the reading.
Mm-hmm.
Now the corner number 3 detected. Now move to the last one. Give him time to correct the readings. And in this time, I prepared the request number 4, the feature ID number 4.
Okay.
Now, after detect the 4 corners, I'll move to detect the obstacles.
All right.
And I'll start with the first obstacle, which is this center wall. And in the same way, but here, rather than corner, I'll write
Obstacle. I see.
And the number is 1.
Okay.
Now, take the first obstacle, I'll move to second one. Here the obstacle is very near to each one, so
you
this 3
you treat them as one.
One, yeah.
Okay, I see. As
the one in the front of the robot direct, so I need just to correct the position of the robot to take it correct.
All right.
And redo again. Now detected, so
okay.
Move to the second one. This one, the third one. Detect the fourth obstacle, moving to the fifth one. And the last one.
All right.
sure that take the correct one. Now detected. Now after detects the obstacles, I'll move to the second task of this course, which is to create the trajectory, simple trajectory task. So now in this task, the first one feature, after detecting the feature, the corner and the obstacles, all of these features now are saved in YAML file. So now if I close this node and go to launch to run the node simple trajectory service, in the first of this node, they go to YAML file and load these corners and load these features and publish it as a static frame. Also, in addition, creating the center frame for calculating the trajectory around it. Now, also in addition, inside it, there is like a function that create a series if point. These points represent the trajectory. So now we can send request to see how is the waypoint frame moving around the environment. So now I send it here before moving to the last task, which is make the robot follow the waypoint.
Okay.
Key feature symbol, trajectory, the interface. Now there is two elements to send a request. First, the start value, which is now true, and the second one if it's clockwise or anti-clockwise. So now clockwise, true. We send it. Now as we can see now the frame, it's moving around the arena. The shape of the trajectory is like a rounded rectangle with a rounded edge, not sharp edge. As you can see now, it's in safe place. Don't reach to any wall. So now we can safely test with the real robot, make it follow the waypoint.
All right. Did you measure? Did you make sure that the clearance was the half the width of the robot?
How? I didn't understand the question. Please repeat.
Did you make sure that the difference between the center of your frame and the wall allowed for the clearance of the robot?
Yes.
I see. Okay, because that can be something that can be overlooked.
Yep. So now when we reach to the point, it started.
All right.
It's stop. So now after make sure that the trajectory is good, so now I'll move to the last task, which is navigate simple navigation that makes the robot follow the waypoint in this arena. So now I'll stop this one, and because now the last task is an action server, we send goal to this action, and this action send request to simple trajectory to run the waypoint move. So for that reason, here I'll use a launch file that it will launch the two nodes, the simple trajectory node and the simple navigation action server.
Okay. Okay.
So now this launch, I also launched RVIZ, but we don't need this one because we are working on that one. It has the map, so I'll close this one, no need for it. And also in addition, in this launch file, I've launched the robot state publisher, which launched the description of the robot, so we can now see it on the map.
Okay.
The real dimension of the robot on the map. So before sending the goal, I'll first.
Hi, Laith. Sorry, we had a bit of a glitch. Can you hear me?
Yes, I can hear you.
All right. So,
so now I sent the goal that ask the robot send the goal to action server that makes the robot follow the waypoint. As we can see now, it's following the way. And when it's complete one run, it will stop.
All right. I see. All right. Very nice. So, just saying on for me, I think we have got a bit of a glitch, so our broadcast was cut short.
Okay.
Let me try to refresh.
Now I still have 4 minutes, so if you wanna, we can
run it.
Send the goal.
Yeah, that would be nice. So just hang on for me. I want us to get reconnected again, so we can see if it's going.
So now I'll start. I send the goal again.
Yep. Okay, just give me 1 sec. I will let you know now.
Sorry, I sent the.
It's okay. It's okay. It's a very nice It's a very nice project. So I think we can get it to. We would love to see it as many times as possible. So that's not a big issue. Okay, it's been. Right. Okay. Now it shows. Okay, it goes nice and around. Okay. All right. It looks pretty good. It looks really good.
Yeah, now it's like going right, left, because I need to tune the gains for the controller again.
Yeah. It's okay. I sincerely apologize for that big glitch, but I think it is important for us to continue broadcasting throughout this because it's a very nice presentation that you have managed to show and demonstrate how it's done. So, without any more on that, I would like to go ahead and ask you a couple of questions with regards to this. So, there are a couple of points that are very important, especially as far as ROS2 TF is concerned. So, the first thing I want us to know is, or I would like you to explain, is how did you implement your feature detection algorithm, right? Because how do you make sure that it differentiates between corners and obstacles? Did you have to look into that, or you just thought, okay, if there's some interference with the laser scan data, then I consider it to be an obstacle? But there has to be some form of differentiating how corners appear and how other obstacles appear. So
sure. So I can explain this in presentation if you wanna presentation slides.
Yeah. Let's do that. It will probably maybe help clarify how.
Okay, so by moving to this chair here. So here about the project overview, the objective was to implement, as we said in also we saw it in the presentation guide. So implement TF-based coordinate tracking. Firstly, detect the features, calculate simple trajectory, and the last task is to create a simple navigation action server. So as mentioned on the presentation guide, I did my presentation slides. So I'll start with the simple navigation. For the simple navigation, firstly, this point or this step doing by the second task, which is simple trajectory. What's happened? The corners and the obstacles that we've already detected and saved in YAML file, loaded and publish it. In addition, we've published the center point, which we calculated the trajectory around it, and also in addition, starting point frame to tell the tester or the user that this point you need to be very near to this point, so your robot can follow the waypoint. So this. The second part is to make sure that our trajectory is working. So our trajectory, it's like a series of 2D points which represent this trajectory. The third thing, step number 3 is making our robot follow the waypoint frame. How we did this? We did this like by calculating the distance between the waypoint frame and our base, our frame for our robot, using the lookup transform method, which returns
the transform between the moving frame and the
yeah,
robot frame.
Between the robot frames, and give us the distance on X and Y. And by calculating this distance, we find the difference between it, and we've taken this distance, and I use it here as a professional controller that control on linear speed and angular speed, and send the command on topic cmdvil to control the robot and make it follow the waypoint. So we can see here in my code here, so we have the dx, take it from the lookup transform. Here we have calculating the distance, and here in this section we can see that calculate here in this section is my controller, proportional controller. Here this is the gains, the gain for linear speed, the gain for angular speed. These values, it's tuned. We can test another values and see what's happened. So these values that which I tuned. So now the second slide, it's about the feature detection, the second task.
Yes, that's what I had asked about. Yeah.
So here, as I said, in this node there is a server. It's how we detect which we want to detect the corner or obstacle by incoming request. So if we send in the request like corner, so there is a function special for corner, and if one obstacle, there is a function special for there is a loop or function special for the obstacle.
Can you take us through the function for the corner? That's the one we want to see first, the implementation for that one.
So the implementation for, did I put it here?
Yeah, for the corner detection algorithm, yeah.
Here I put picture, I'm not sure, I'll open the code to see you, but here it's in very simple way. What I did, I calculate, I use a function from OpenCV library. This function like make or fit line between the first point
Mm-hmm.
and the last point of my range.
Okay.
Yeah, so after fitting the point, how it detect the corner, he calculate the distance for each point, and the furthest point it's represent the corner.
Okay. All right. I see. I see. So your robot has to be aware that it's actually trying to detect a corner, and then it would mark the 2 points before trying to find the furthest distance of both of
The
them.
furthest point, yeah, which represent the corner.
Okay. All right. All right. Pretty good. Pretty good. Okay, you can go on.
And for obstacles, I consider any shape that is not like a wall, any shape or any shape that robot can move around it as an obstacle, and I detect it by make sure that that shape in the front of the robot direct, so it's come on the front in the center index of the lidar values,
Uh-huh.
and give it like an frame.
Okay. So how do
And
you um how do you let me say, how do you make sure that the things that are being detected by your robot are obstacles and not the wall, right? Did you have to implement any specific differentiating mechanism so that your robot is aware that the this is a wall and this is an obstacle, or you
no,
just
I didn't that.
okay
No, just like calculate the distance and take the point.
okay, so which means in this case you're basically relying on the fact that the robot is facing something that is an obstacle. So
Yeah.
okay, all right, I see.
So how I think about it, I think about it if my robots can move around it,
Mm-hmm.
make a turn around it, it's like an obstacle. So and this obstacle is in ahead of my robots, so direct give it like an odom and publish it as static frame.
Okay. All right. All right. It's a very nice presentation. So it's unfortunate that we are out of time, but would love to have had you explain a little bit more. So, very well done, Laith. Very well done. Very nice presentation.
Okay.
All right. All right, everyone. This was Late's presentation. Very warm congratulations to him. It was a very nice demonstrative way of showing how to do this, and would like to really, really congratulate him. So, for any of those who would like to give this project a shot, we highly encourage you to do so. And until then, keep pushing your ROS learning. Bye bye.